So this greenhouse is pretty unique. It's a ground bed where we actually have 3 feet of soil so that the plants can really put their roots down and stretch and grow to their full potential. When we first worked in this space, this ground bed was filled with sort of the equivalent of kitty litter, like little rock particles and dust, and the plants didn't like growing in it. So we were growing pots on top of that, and it seemed kind of silly to be filling pots up with soil to have them sit on top of a soil bed. We worked with the greenhouse staff to extract all of the old kitty litter material, and then we filled it back with a topsoil blend. So this turns out to be very different plants than if they were just in pots where they're root bound and you have to control all the macro and micronutrients. You know, they're able to extract that by themselves from the soil, and you end up with much healthier plants. What this greenhouse space allows us to do is actually grow 3 generations a year, where we can go out of the field and into the greenhouse, get a generation in this ground bed, harvest that, plant it back in the spring, and have enough time to harvest it before it's planted again in the summer. Now, the reason that that's important is when you're doing genetic experiments in breeding, like we are for enhancing biomass, plant productivity, increasing the sugar content. The breeding cycle is so important. The more generations you can get through a year, the greater your genetic gain, and the faster you can sort of achieve that ultimate outcome. So the next generation of what you see here will get packaged, treated, and then will be planted out in the field by a tractor first week of June. We've also tried to optimize all other aspects of the growth conditions. So we modulate the temperature. We have these LED light systems in here so we can increase the light intensity, but also manipulate the day length so that we can turn our generations faster. And then we control the water. So you can see along the ground, we have a fertigation system where we can pipe through water, fertilizer, and then we can cut it at the appropriate time to increase the speed of the dry down that allows us to make our generational turns. And so really, if you think about what it takes to grow a plant, we're controlling every aspect of that in this space. The plants that you see here now are the product of a lot of labor that goes in on the front end of this process. So we plant a couple thousand seeds into flats, and we grow those up into seedlings, and then my students extract the DNA from each one of those individual seedlings, and we do some genotyping. So we run molecular markers to look at the genetic composition of those individuals, and then the ones that we want, they get transplanted here into this ground bed. And so most people, if you see it at this stage, you know, there's 300 plants in this room or something like that, but they don't see the 2,000 plants and all of the labor to get us narrowed down to these sort of elite 300 that we want to keep, that we then grow to full maturity. There's a couple major goals that we have in my lab related to the sorghum. One of those is to try to increase the amount of sugar that the plant produces through the juice volume and then also the concentration of the sugar. And so we're playing with polyploid sorghum that we generated here at the university as part of CABBI to increase the stem size and the overall productivity of the plants. The other thing that we're focused on is changing the way the plant allocates its photosynthate. So it's taking in all this wonderful sunlight and CO2, it's turning that into some kind of carbon compound in the plant. We're trying to get the plant to direct that to the sugar part that we can harvest, and so we can manipulate the plants to change their source-sink relationship. In the scheme of CABBI, we're really excited about these sorghum lines that we're developing because there's really not a sugar market that's available for sorghum here in the Midwest. And so if we could increase the amount of sugar that we can produce in sorghum, it would actually reach an economic threshold where it would be valuable to grow it, and it would compete well with sugarcane that's grown in the southern United States. We're hoping that it opens up a whole new market for farmers here in the Midwest where they could grow a bioenergy crop that has a fermentable sugar that can be used for either just regular ethanol or sustainable aviation fuels. And it's also a highly stress tolerant crop, and so we could diversify maybe their farm portfolio a little bit and, like I said, open up a new market.